The models are no longer speculating. As of this week, every major forecasting system on the planet, the European Centre, NOAA's climate forecast system, and the Australian Bureau of Meteorology has converged on the same conclusion. A Super El Niño is forming in the Pacific Ocean right now, and it is not a distant threat. The atmospheric fingerprints are already showing up inside the June forecast for the United States. The jet stream is shifting, the heat is building, the storm tracks are changing, and for millions of Americans this summer is going to feel completely different from anything they have experienced in recent memory. In this video, I am going to walk you through exactly what is happening, why the data is so alarming, and what it means for your area through the rest of June and well into July. We are talking about record-breaking ocean temperatures, an accelerating Kelvin wave, a suppressed Atlantic hurricane season, an elevated wildfire threat across the western United States, and a severe weather corridor that is going to stay active for weeks. This is one of the most consequential pattern shifts I have seen in years, and I want to make sure you understand all of it. I am Arthur, and this is Sky Space Lab. If you are new here, this channel is where we track the data, the real numbers, the actual model output, the sources that matter. Hit subscribe so you do not miss what is coming. Because over the next several weeks, this story is going to get bigger, not smaller. Let us get into the data. We need to start with what is happening right now, this week, because El Niño's influence is not some abstract future scenario anymore. It is already showing up in real-time satellite data, in the current jet stream configuration, and in the active weather pattern across the central United States. The first thing to understand is the Nino 3.4 index. That is the primary benchmark scientists use to measure El Niño's intensity. As of late May into early June of this year, the Nino 3.4 index surged to plus 0.9 degrees Celsius. That is nearly double the official El Niño threshold of plus 0.5, and it is accelerating, not leveling off. NOAA's Climate Prediction Center is now placing an 82% probability that El Niño will be officially declared between May and July of 2026. The same agency gives a 96% chance that El Niño conditions will persist all the way through the Northern Hemisphere winter of 2026 into 2027. Here is the part most people are not paying attention to yet. The Kelvin wave driving this event is carrying subsurface temperature anomalies of plus 8 degrees Celsius below the ocean surface. That is warmer than the same stage of development during the 1997-98 Super El Niño, the event that is widely considered the benchmark for what a powerful El Niño can do to global weather. Now, two peak anomaly numbers are circulating right now, and I want to make sure you understand what each one means. The first is plus 3 degrees Celsius. That is the projected peak in the Nino 3.4 region, the standard Central Pacific monitoring zone that ECMWF, NOAA's climate forecast system, and Australia's Bureau of Meteorology have all converged on. The Super El Niño threshold is 2 degrees. 3 would match or surpass the 1997-98 benchmark. The second number, plus 4.5 degrees, refers to the Nino 1+2 region off the coast of South America, which runs significantly hotter than the Central Pacific during strong events. These are two different measurement zones of the same ocean. Both numbers are real. They do not contradict each other. They describe different parts of the same historic warming signal, and together they point toward an event that could rewrite the record books. So what is happening in the United States right now, today? The first El Niño atmospheric signals are now detectable in the June forecast. Severe Weather Europe published analysis this week showing the velocity potential forecast, a parameter that reveals areas of rising and sinking air in the atmosphere, is already displaying a clear El Niño cell configuration over the Pacific. In plain language, that means the atmosphere is already reorganizing itself in response to the warming Pacific. And that reorganization is producing real weather consequences across the country right now. Here is who needs to watch this the most in the coming days. The central and northern plains, from the Dakotas down through Nebraska and Kansas, are sitting under an active severe weather pattern this week driven by strong jet stream energy working into an omega block configuration. Areas including Rapid City, Aberdeen, Sioux Falls, Fargo, and Grand Forks are in the bullseye for rounds of severe weather through at least Thursday. The Storm Prediction Center has maintained multiple slight risk areas across the northern plains over consecutive days. Supercells capable of producing large hail up to 2 inches in diameter, damaging wind gusts near 70 miles per hour, and isolated tornadoes remain on the table. The atmospheric instability across the region is running at 2,000 to 3,000 joules per kilogram, more than enough fuel for organized convection. And while this week's severe weather is driven by the current omega block pattern, El Niño is already influencing how long this active stretch persists and where it will go next. The flooding threat is also elevated this week. Models are indicating slow-moving storm systems across Nebraska and Kansas that will backbuild overnight, meaning new storms fire on top of where rain already fell. Rainfall totals of 3 to 5 inches over a short period are possible across portions of the Central Plains. Flash flood watches may be needed across these areas. If you live near a low-lying area or a known flood-prone creek or river in Nebraska, Kansas, or western Iowa, you need to have a plan ready now, not after water starts rising. The southeastern United States is also in the picture. A frontal boundary draped across the Gulf Coast states from Texas through Florida is keeping moisture and instability locked in place. Isolated severe storms are possible along this boundary from Houston to Tallahassee through the middle of the week. The main threat there is damaging wind gusts and large hail, with the tornado risk remaining low but not zero. Drop a comment right now and tell me where you're watching from and whether severe weather has already impacted your area this week. I read every single one. But here is where the story takes a turn. The pattern driving all of this activity is not going away, it is evolving. Looking at the 7-day forecast from today, Sunday the 7th of June, out through Saturday the 13th, the active weather pattern across the central United States is going to persist and shift. Let me walk you through it day by day. On Monday the 8th, the severe weather threat shifts slightly east and south. Northern Nebraska, southern South Dakota, and northwestern Iowa come into focus for the primary risk area. An upper-level low anchored over southern Canada continues to spin energy into the plains. Isolated supercells are possible during the afternoon hours of Monday, with the window for tornado development opening between 3 and 7 in the evening. The overnight hours bring the risk of storm clusters producing damaging winds as cells merge into a convective system, pushing toward Minneapolis and La Crosse. On Tuesday the 9th, the storm energy tracks further east. The threat drops across the plains but picks up across the upper Midwest. Look for a severe weather corridor developing from eastern South Dakota, across southern Minnesota and into Wisconsin. The jet stream energy is progressive on Tuesday, meaning storms should move quickly and limit the tornado threat, but large hail and wind gusts are still well in play. By Wednesday the 10th, Colorado State University is scheduled to release its updated June hurricane season forecast. That update is going to be critical, and I will have full coverage for you. On the weather side, Wednesday looks quieter across the plains as the upper-level low finally pulls away to the northeast. But the break will be brief. The latest GFS and European ensemble runs both show a new system emerging out of the Pacific Northwest by Thursday the 11th. This is directly tied to the El Niño-driven Pacific jet extension that is now becoming the dominant pattern. Forecasters have been watching this setup because the Pacific jet is running unusually strong for June, one of the strongest extensions I've seen during this time of year. This new system drops into the Rockies and begins pulling moisture northward out of the Gulf of Mexico. By Friday the 12th and Saturday the 13th, another round of severe weather is likely from Colorado and Wyoming southward through Texas and northeastward into the Midwest. The Friday and Saturday window is still carrying uncertainty at this range, but the trend in both models and ensembles is pointing toward organized activity, not just scattered storms. Here is what I want you to take away from this 7-day picture. The upper Midwest, including Indiana, Ohio, and Michigan, has seen almost no severe weather over the past 30 to 40 days. That quiet streak is about to end. These regions are heading into their peak meteorological window for severe weather right as this new pattern shift arrives. If you are in Indiana, Michigan, or Ohio, now is the time to update your severe weather plan and make sure you know your local NWS office's watch and warning protocols. Rainfall totals through next weekend could be significant across the Midwest. Model output suggests Grand Forks could see close to 5 inches of rain between now and the 13th of June. Sioux Falls, Minneapolis, and Fargo are all looking at 3 to 4 inches. After weeks of below-normal precipitation across much of the upper Midwest, driven by that omega block high-pressure system, this moisture is desperately needed. But heavy rain arriving quickly on hard, dry ground creates a flash flood risk. Monitor conditions carefully. Most channels are not showing you this part, but it matters. The summer pattern that is now locking in across the United States is not just a week-long event. It is a season-defining shift. To understand what is coming in July, August, and beyond, you need to understand what is breaking down right now. Let me explain what is happening in the atmosphere. For most of this spring, the dominant pattern across the United States was what meteorologists call an omega block. Picture the Greek letter omega, a ridge of high pressure sitting over the southern plains, flanked by troughs on either side. That pattern kept the Pacific jet stream pinned to the north, created persistent heat across the southern tier, and generated the relentless severe weather we have seen week after week across the central plains. That omega block is now breaking down, and what replaces it is directly tied to El Niño. As the tropical Pacific warms and the Kelvin wave pushes toward the surface off the coast of South America, it disrupts and weakens the Walker cell circulation in the atmosphere. Under normal conditions, the Walker cell drives warm air upward over the western Pacific and Indonesia, carries it eastward at high altitude, sinks it over the central and eastern Pacific, and returns it westward near the surface. El Niño breaks that pattern. The warming of the central and eastern Pacific shifts the zone of rising air eastward, weakening the trade winds and the entire overturning circulation. That disruption is what reorganizes the global jet stream, pumping energy into the Pacific jet and driving it eastward into North America with unusual force. The Pacific jet extends dramatically, carrying storm systems and moisture into the American west and southwest. Simultaneously, the polar jet buckles northward over western Canada and Alaska, creating warmth there while allowing cold fronts to dig periodically into the Great Lakes, Midwest, and Northeast. NOAA's Climate Prediction Center temperature outlook for mid to late June reflects this clearly. Above normal temperatures are forecast across the western and central United States, particularly from the Pacific Northwest, through the Rocky Mountain states and into the southern plains. The core heat anomaly is running 4 to 6 degrees Fahrenheit above normal across interior California, Nevada, Oregon, and Idaho. That is not a heat wave in the classical sense. It is a sustained period of above-normal warmth that builds cumulative heat stress on agriculture, water resources, and energy infrastructure. Daily high temperatures in cities like Phoenix, Las Vegas, and Albuquerque will routinely push into the 100 to 110 degree range through the middle of June and beyond. For the Pacific Northwest, Washington, Oregon, and northern Idaho, this pattern brings both heat and drought. Soil moisture is already running well below normal across much of this region after a dry spring. The El Niño signal amplifies that dryness. Historical analysis from past Super El Niño events shows significantly elevated wildfire risk across the northwest during summer months. The combination of below-normal precipitation forecast through at least mid-July, above-normal temperatures, and existing dry vegetation creates a concerning setup for large fire development. If you are in western Montana, northern Idaho, eastern Washington, or eastern Oregon, fire conditions could deteriorate rapidly during any period of sustained heat and wind. Meanwhile, a completely different story is unfolding east of the Rockies. The strengthened Pacific jet is not just bringing heat to the west, it is also funneling active weather into the central and eastern United States through a more energetic storm track. The ECMWF Extended Range Forecast, which now runs out to 16 days with meaningful signal, shows a succession of low-pressure systems rotating through the northern tier from the Pacific Northwest into the northern plains and Great Lakes. This is the storm track that El Niño tends to drive during summer, not across the south, but through the middle and northern latitudes, bringing repeated rounds of instability to the Midwest, Ohio Valley, and Northeast. The Derecho Potential Index, a measure of how favorable the atmosphere is for long-lived, fast-moving windstorm systems, is running elevated for large portions of the Midwest through the summer. NOAA's Derecho seasonal forecast identifies a high probability corridor from South Dakota through central Kentucky, including Iowa, Missouri, Illinois, Indiana, and eastern Nebraska. These fast-moving convective systems can produce winds in excess of 70 to 80 miles per hour across a swath hundreds of miles wide in just 12 to 24 hours. They are particularly dangerous because they develop and intensify quickly, often with limited warning time. Here is where both models just made a significant move that I want to flag for you. Both the GFS and the European model are now showing a significant pattern shift around the 10th to the 15th of June, and their agreement on the timing has strengthened in the latest runs compared to 48 hours ago. The high pressure that has been anchored over the eastern United States, blocking much of the moisture and storm activity, begins to retrograde westward. As it does, It opens the door for a more aggressive subtropical jet to push northward from the Gulf of Mexico. That delivers a massive pulse of moisture into the Mississippi Valley, the Midwest, and eventually the Ohio Valley and Northeast. This is the setup that historically produces the most organized severe weather of the early summer season. Not single supercell events, but multi-day outbreaks with elevated tornado potential. I am watching the June 10th through 15th window very closely. If the models verify, this could be the most significant severe weather period across the central United States so far this year. I will be updating you on this daily. Let me also talk about the agricultural impact that almost no weather channel is covering right now, because it has real consequences for every American, not just farmers. The Central Plains and Midwest are the engine of American food production. Corn, soybeans, winter wheat. Tens of millions of acres that depend on reliable summer rainfall and manageable temperatures. The pattern that El Niño is driving for this summer creates a split that agricultural meteorologists are watching closely. On the positive side, the active storm track and above-normal rainfall potential for the upper Midwest through June is going to help corn and soybean crops that were planted into stressed soils after a drier-than-normal spring across Iowa, Illinois and Indiana. Timely rainfall now, even if it comes with severe weather risk, is critical for crop establishment. The USDA's weekly crop progress reports have already shown below-average soil moisture conditions across the Corn Belt entering June. Several rounds of significant rainfall through mid-month could shift that picture meaningfully, but here is the other side of that coin. For Kansas, Oklahoma, and the winter wheat belt, the story is more complicated. Winter wheat harvest is already underway across parts of southern Kansas and Oklahoma. Any storm system producing large hail, which is exactly what we are tracking this week, can shred a standing crop in minutes. Several severe weather events have already impacted portions of the wheat belt over the past 30 days. El Niño's active severe weather pattern raises the statistical probability of additional hail events through the remainder of June. And for the Pacific Northwest, where a significant portion of America's apple, cherry, potato, and wine grape production is concentrated, the warm, dry summer signal is extremely concerning. Washington state alone accounts for roughly 70% of America's apple production. Cherry crops in the Yakima Valley and Wenatchee region are critically sensitive to heat and drought stress during the late spring and early summer period. Temperatures running 4 to 6 degrees above normal through June and July in this region could accelerate ripening, reduce fruit quality, and stress orchards that have already had a challenging season. So what you are really looking at is not just a weather story, it is an economic story, an agricultural story, a water story. El Niño at this scale reshapes the conditions that determine food prices, energy costs, water availability, and wildfire suppression expenses across the entire nation. I think it is important to understand that this summer's weather is not going to be an isolated set of events. It is a connected system driven by a single, powerful forcing mechanism sitting at the bottom of the Pacific Ocean. Now let us talk about the water supply dimension. The western United States has spent the past several years recovering, slowly and incompletely, from the mega-drought conditions that dominated the early part of this decade. Snowpack levels in the Sierra Nevada, the Cascades, and the southern Rockies came in below average across much of those ranges this past winter. Reservoirs across the interior west are not at the critically low levels seen during the worst of the drought years, but they are not robust either. And here is the problem. El Niño summers historically bring reduced precipitation to the Pacific Northwest and the northern Rockies, precisely the regions where summer glacier melt and residual snowpack contribute to river flows that feed irrigation systems, hydroelectric generation, and urban water supplies. The Columbia River Basin, which powers hydroelectric facilities serving millions of Pacific Northwest homes, could see reduced flow by mid to late summer if the dry signal verifies. That has implications for electricity prices and grid reliability during the peak summer heat demand period. Here is something that almost nobody is talking about yet, and it could directly change the temperature forecast for your area, even if you are nowhere near a wildfire. The feedback loop between El Niño, western drought, wildfire smoke, and the summer heat pattern across the eastern United States is one of the most underappreciated weather dynamics of recent decades. When large wildfires burn across the Pacific Northwest, Montana, and Idaho, as the current setup increasingly suggests they could, the smoke plumes travel eastward on the jet stream. That smoke serves as a wild card in the temperature forecast for the Great Plains and Midwest. dense smoke layers can actually reduce daytime high temperatures by 5 to 10 degrees Fahrenheit in affected areas by blocking incoming solar radiation, while simultaneously raising overnight lows. This creates unusual temperature profiles that can destabilize the atmosphere in unexpected ways when it interacts with the frontal boundaries and moisture plumes already in place across the central United States. I will be watching smoke transport patterns closely throughout the summer for exactly this reason. It is an additional layer of complexity that most forecasters do not account for in their Week 2 outlooks, but it can have meaningful short-term impacts on severe weather potential across a broad area. Now I need to take you to the part of this story that every coastal community needs to hear, and that is what El Niño means for the Atlantic hurricane season that opened just days ago. The Atlantic hurricane season officially opened on June 1st, and here is what happened on day 1. Nothing. Zero tropical activity, not a single tropical depression, tropical storm, or any organized system anywhere in the Atlantic basin. Satellite imagery showed dry air and strong upper-level winds across the entire main development region, the stretch of ocean from the Lesser Antilles all the way to the coast of Africa. That is not a coincidence. That is El Niño doing exactly what it does. Let me give you the numbers. Colorado State University, the institution that pioneered seasonal hurricane forecasting in 1984, released its April 2026 outlook, calling for 13 named storms, 6 hurricanes, and 2 major hurricanes of Category 3 intensity or higher. That is the fewest storms CSU has predicted since 2019. More significantly, the ECMWF ensemble model is projecting vertical wind shear across the main development region at levels that would be the second highest recorded since 1981. The only year with higher shear in that record was 2015, also a Super El Niño year. That season produced just 11 named storms. NOAA's official outlook, released May 21st, calls for 8 to 14 named storms, 3 to 6 hurricanes, and 1 to 3 major hurricanes. NOAA assigns a 55% probability of a below-normal season, 35% near normal, and just 10% above normal. The Nino 3.4 index is 98% likely to reach El Niño threshold during the peak of the season, and the sheer suppression that forecasters have been predicting is now showing up in real-time data. CSU's June forecast update drops on June 10th. I will be covering it in full. But the signal from both deterministic and ensemble models going into that update is not trending toward an upward revision. The El Niño fingerprint is too strong. Now here is the critical caveat that every serious meteorologist has to state. A below-normal season does not mean a safe season. The 1997-98 Super El Niño year, widely considered the strongest modern El Niño on record, still produced Hurricane Pauline, a storm that killed hundreds of people in Mexico, even during the 2015 Super El Niño season, when shear was running at record levels across the main development region. Hurricane Joaquin still reached Category 4 and devastated the Bahamas. El Niño suppresses the Atlantic basin on average, but outliers happen. Warm Atlantic sea surface temperatures, which remain elevated this year, can partially offset the shear from El Niño if any individual storm manages to tap into a favourable break in the shear pattern. There is actually a significant scientific debate happening right now about this exact tension. The University of Arizona is forecasting 20 named storms for 2026, arguing that Atlantic sea surface temperatures are warm enough to overpower El Niño's shear. CSU is at 13. That disagreement, between 20 and 13, represents an extraordinary range of uncertainty for a season that is already underway. The data I trust most right now is the real-time shear analysis. And on June 1st, that shear was already visible in the satellite data. El Niño is winning the early rounds. But here is where the Pacific side of this story becomes even more important. While El Niño suppresses the Atlantic, it simultaneously energizes the Eastern Pacific hurricane basin. Sea surface temperatures in the Eastern Pacific are already significantly above normal. The positive Pacific meridional mode is in place, driving anomalous warmth from the Central Pacific toward the coast of Mexico and Central America. The National Hurricane Center has been monitoring multiple areas of development in the Eastern Pacific over the past week, with one area carrying a 20% chance of formation in 7 days west of Central America. That probability is likely to rise. Historically, active Eastern Pacific seasons during El Niño years produce storms that occasionally threaten Mexico and can send significant moisture plumes northward into Arizona, New Mexico, Texas, and even the Great Plains. That moisture interaction with the already active severe weather pattern across the central United States could produce some of the most intense storm events of the summer. I will be watching every Eastern Pacific development closely for exactly this reason. Now let us zoom back out to the biggest picture. What we are witnessing in the first week of June 2026 is the beginning of a multi-month atmospheric regime change. The ECMWF seasonal model is projecting peak anomalies exceeding plus 4.5 degrees Celsius in the Nino 1+2 region, the zone directly off the coast of South America that runs hottest during strong events. In the standard Nino 3.4 monitoring region, the projected peak sits at plus 3 degrees Celsius, still well above the Super El Niño threshold of 2 degrees, and on par with or exceeding the 1997-98 benchmark. If that verifies, it would rival, and potentially surpass, the strongest El Niño event in the historical record going back to 1877. The last time anomalies reached comparable levels was during the 1997-98 event. That Super El Niño contributed to record flooding in California, catastrophic droughts in Australia and Southeast Asia, devastating wildfires in Indonesia, and significant disruptions to the monsoon pattern across South Asia. The 2026 event is developing faster and from a warmer baseline, because global average temperatures today are already higher than they were in 1997. NOAA's climate forecast system and the ECMWF models have now converged on peak sea surface temperature anomalies of plus 3 degrees Celsius or higher, the threshold for a Super El Niño designation. ECMWF's probability tracker went from 22% in March to 80% in April to 100% in May. That acceleration is steeper than either the 1997 or the 2015 Super El Niño events. The IRI, the International Research Institute for Climate and Society at Columbia University, now places a 98% probability on El Niño development. The most recent subsurface ocean temperature analysis from NOAA still shows the Kelvin wave propagating eastward with anomalies well above the depth average values seen during the 1997 event at the same stage of development. The warm supply from the Western Pacific has not been exhausted. That means the Kelvin wave has not yet reached its peak energy delivery to the surface. The worst of the ocean warming, and therefore the strongest atmospheric response, is still ahead. For the United States, what does a record-strength Super El Niño mean through the rest of the summer and into fall? Let me give you the regional breakdown based on verified historical analysis from NOAA. The Pacific Northwest, Washington, Oregon, northern Idaho, and western Montana, faces the clearest and most dangerous signal. Warmer, drier conditions are the historical norm during Super El Niño summers in this region. The drought risk is elevated. Wildfire conditions could become extreme by late June and July. Water supply concerns are real for agricultural users who depend on snowpack-fed rivers that are already running below normal. The Southwest, Arizona, New Mexico, southern Utah, and southern Nevada, gets a complicated signal. El Niño enhances the North American monsoon by driving warmer Gulf of California sea surface temperatures. That means monsoon moisture could arrive earlier and more aggressively than normal across Arizona and New Mexico this summer, bringing the potential for extreme flash flooding in areas with dry, compacted soils. At the same time, the pre-monsoon period through the end of June will be hot and dry. Phoenix, Tucson, and Albuquerque should expect dangerous heat conditions with daily highs well into the 100 to 115 degree range before the monsoon arrives. The Midwest and Central Plains, from the Dakotas through the Ohio Valley, are in the most active zone for the pattern that El Niño is driving. Above normal rainfall combined with an active severe weather track means this region is looking at a summer with more frequent and potentially more intense storm events. The Derecho corridor from South Dakota to central Kentucky is the primary concern, but tornado potential also remains elevated throughout the region. The lack of severe weather across Indiana, Ohio, and Michigan over the past 30 to 40 days is ending. These areas are heading into their statistically most active period, right as El Niño's jet stream influence takes full hold. The southeast, from Georgia through the Carolinas and Florida, sees an interesting signal. El Niño drives increased precipitation across the southern United States through the enhanced subtropical jet. Florida in particular tends to see above normal rainfall during El Niño summers, but the Atlantic hurricane suppression means less tropical moisture contribution. The net result is a summer that could be wetter than normal, but less threatening from a tropical perspective for much of Florida and the Gulf Coast. The caveat remains, one determined hurricane that finds a break in the shear can still cause catastrophic damage regardless of El Niño's average suppression. The northeast and mid-Atlantic, from Virginia through New England, will experience a pattern driven largely by what happens with the storm track across the Great Lakes. If the Midwest sees active derecho and severe weather weeks as expected, moisture and energy from those systems will pulse eastward into the northeast. Above normal precipitation is likely through much of June and into July for areas from Washington, D.C. north through Boston. Temperature anomalies for the northeast may actually run near normal to slightly below normal during periods of active weather, with above normal heat arriving only when high pressure temporarily dominates. Now I want to go deeper on the tropical picture, because there is a lot of confusion out there right now about what El Niño actually means for hurricane risk along the Gulf Coast and East Coast. Let me be precise. El Niño suppresses the Atlantic basin primarily through one mechanism: vertical wind shear. Shear is the change in wind speed and direction with altitude. When shear is high across the main development region, it literally tears developing tropical cyclones apart before they can organize into a cohesive, intensifying system. The ECMWF ensemble model is currently forecasting shear levels across the main development region that would rank as the second highest in the 43-year record back to 1981, with only 2015, another Super El Niño year, exceeding it. That is an extraordinary shear environment, but here is what I need you to understand about that number. Averages and records describe the basin-wide picture. Individual storms do not follow averages. During the 2015 season, that record-high shear year, the Atlantic still managed to produce Hurricane Joaquin, which struck the Bahamas at Category 4 intensity. During the 2023 El Niño season, when the tropical forecasting community was nearly unanimous in predicting a quiet year, the Atlantic produced 19 named storms and multiple major hurricanes, because record-warm Atlantic sea surface temperatures overpowered the shear in case after case. The debate happening right now between CSU at 13 named storms and the University of Arizona at 20 named storms is not just an academic disagreement. It reflects a genuine scientific uncertainty about which force is going to win this year: El Niño's shear or the Atlantic's exceptional warmth. NOAA's official forecast range of 8 to 14 named storms acknowledges that uncertainty with an unusually wide spread. What does this mean practically? If you live along the Gulf Coast, from Brownsville to Tampa to New Orleans, you should not look at a below-normal seasonal forecast and conclude that the risk is low. The risk is lower than average. It is not zero. It is never zero. A single landfalling major hurricane carries the same destructive potential in a quiet season as it does in an active one. Your hurricane preparedness plan should be fully in place before July. Make sure your insurance is current, your evacuation route is identified, and your emergency kit is stocked every single year. The Eastern Pacific tropical picture deserves its own segment because it is genuinely active right now, and it is getting less attention than it deserves. The National Hurricane Center has been monitoring multiple disturbances in the Eastern Pacific over the past week. Sea surface temperatures west of Central America and south of Mexico are running well above normal, boosted by the same Pacific meridional mode warming that is driving the El Niño development. El Niño historically produces more frequent and more intense Eastern Pacific tropical cyclones. The mechanism I want you to understand is moisture transport. When a tropical system develops in the Eastern Pacific and tracks westward or northwestward toward Mexico, it does not have to make landfall to affect weather across the United States. The circulation associated with a strong tropical storm or hurricane in the Eastern Pacific can act like a giant pump, drawing tropical moisture northward into Mexico and then into Arizona, New Mexico, Texas, and even the Central Plains. This is the tropical moisture interaction that severe weather meteorologists watch closely during El Niño summers. It can juice instability across the plains well above what the standard model parameters suggest, turning an otherwise ordinary severe weather day into something significantly more intense. The Eastern Pacific is boiling right now. I am watching every disturbance in that basin with the same attention I give to Atlantic development, because the downstream effects on the United States are real, and they are coming. Let me also address something that I know is on a lot of your minds based on the comments and questions I've been receiving. People are asking whether this El Niño, potentially this record-breaking Super El Niño, is being amplified by climate change. The scientific answer is yes, almost certainly. climate scientists from NOAA, NASA, and multiple peer-reviewed institutions have documented that El Niño events occurring against the backdrop of elevated baseline global temperatures produce more extreme downstream effects than the same strength event would have produced decades ago. The ocean is warmer to start with. The atmosphere holds more moisture. The jet stream anomalies that El Niño drives are operating on a warmer, more energetic atmospheric base state. That does not change the physics of what El Niño does. It amplifies the magnitude of those effects. Flooding is wetter, droughts are drier, heat waves are hotter. And the storm systems that these patterns generate have more moisture and energy to work with. A December 2025 study in Nature Communications specifically examined the interaction between Super El Niño events and elevated global baseline temperatures. The findings indicated that events of this character, occurring when global average temperatures are already at or near record levels, carry substantially higher risk of producing regional extremes outside the historical envelope, meaning conditions that have no clear precedent in the observational record. That is not alarmism. That is what the peer-reviewed science says, and it is why I take this particular setup more seriously than I would a standard El Niño development. When GFS and Euro agree on something like this, you pay attention, and right now, they are both telling the same story about the second half of June and the summer beyond. The pattern that is locking in over the next 2 to 3 weeks is not a weather event, it is a seasonal regime, and it is being driven by an ocean that is warming faster than any of our current forecast models fully anticipated just 3 months ago. I want to leave you with this thought. The 1997-98 Super El Niño caused over $35 billion in damage in the United States alone, in 1997 dollars. It triggered catastrophic flooding in Northern California, drought conditions across the southeast, a remarkably quiet Atlantic hurricane season, and one of the most active tornado seasons on record across the southern plains and Midwest. The 2026 event is developing from a warmer starting point, with a faster acceleration of the Kelvin wave and against a background of elevated global temperatures that amplify the downstream effects of every climate signal. This is not business as usual. The data is telling us something important, and I am going to keep bringing that data to you every single day. Tomorrow I will be watching the mid-range models closely for the June 10th through 15th severe weather window across the Midwest. I will also have full coverage of CSU's updated June hurricane forecast the moment it drops on June 10th. If significant changes emerge in the El Niño data from NOAA's upcoming ENSO diagnostic discussion, I will break that down for you immediately. Make sure you are subscribed so you catch every update. This is one of the most important weather patterns of the decade, and it is just getting started. And one last thing before you go, drop your take in the comments. CSU says 13 named storms this Atlantic season. The University of Arizona says 20. El Niño shear dominates, or warm Atlantic sea surface temperatures break the pattern. Which side are you on?